I will see a problem in quantum mechanics. The problem is a particle in the harmonic oscillator. Potential starts out in the state psi of x comma 0 is equal to a 3 psi 0 of x plus psi 4 psi 1 of x. Find a and construct psi of x comma t and modulus of psi of x comma t squared and find the expectation value of position and momentum. Check that the Ehrenfest theorem holds for this wave function. Next, you have to find if you are measured the energy of this particle, what values might you get and with what probabilities. So the wave function for the harmonic oscillator at n is equal to 0 is psi 0 is equal to m omega by pi h cross whole power 1 by 4 e power minus m omega by 2 h cross x squared. If you use the ladder operator a plus, that is 1 by 2 h cross m omega minus h cross d by dx plus m omega x, we can find out wave function psi 1 for n is equal to 1. So it is equal to a plus acting on psi naught. So you can get psi 1 as 1 by 2 h cross m omega by pi h cross whole power 1 by 4 2m omega x e power minus m omega by 2h cross x squared. So given wave function is psi of x comma 0 is a into 3 psi naught plus 4 psi 1. So and also now you have to find out the value of a, that is you have to find normalize the wave function. So integral from minus infinity to plus infinity psi of x comma 0 star and psi of x comma 0 dx equal to 1. Now you substitute the value of psi of x comma 0 from equation 5. We can get it is modulus of a squared integral from minus infinity to plus infinity 3 psi naught star plus 4 psi 1 star into 3 psi naught plus 4 psi 1 into dx is equal to 1. So if you substitute this and also we can get it is psi 9 psi naught star psi naught plus 16 psi 1 star psi 1 plus other two terms with psi naught star and psi 1. So the first two terms has the value of 1, otherwise other two terms have the value 0. So it is modulus of a squared into 9 plus 16 is equal to 1. So from this we can calculate a is equal to 1 by 5. So the normalized wave function is psi of x comma 0 is 1 by 5 3 psi naught plus 4 psi 1. Now you have to construct psi of x comma t. Psi of x comma t is 1 by 5 3 psi naught into e power minus I e naught t by h cross plus 4 psi 1 e power minus I e1 t by h cross. Here e naught and e1 are the energies associated with the wave function psi naught and psi 1. So if you substitute En is equal to n plus half h cross omega, and we can get the value as psi of x comma t is equal to 1 by 5 3 psi naught e power minus I omega t by 2 plus 4 psi 1 e power minus I 3 omega t by 2. So if you take the modulus squared, we can get uh, it is 1 by 25 3 psi naught e power I omega t by 2 plus 4 psi 1 e power I 3 omega t by 2 and into 3 psi naught e power minus I omega t by 2 plus 4 psi 1 e power minus I 3 omega t by 2. So if you multiply and also if you substitute the integral, and we can get it is modulus of psi of x comma t the whole squared is equal to 1 by 25 9 psi naught squared plus 16 psi 1 squared plus 24 psi naught psi 1 cos omega t. Now we have to find the expectation value of x. So it is integral psi star x psi dx. If you substitute the value of the wave function and also if you multiply, and the first term is you are getting integral x psi naught square dx and another one is x psi 1 square dx, and these two are it's an odd function, so the integral becomes 0. So only you have the last term, that is 24 by 25 integral from minus infinity to plus infinity x psi naught psi 1 cos omega t dx. So now you substitute the value for psi naught and psi 1, you will get it is 2 by pi whole power half m omega by h cross cos omega t integral from minus infinity to plus infinity x squared e power minus m omega by h cross x squared dx. And now we have to find the integral. So here it is an even function, so we can write it is 2 into integral from 0 to infinity x squared e power minus m omega by h cross x squared dx. And also here now you let m omega by h cross x squared as t, so it is m omega by h cross 2x dx is equal to dt. So x is equal to h cross by m omega whole power half t power half. So if you substitute all these terms, we will get it is h cross by m omega whole power 3 by 2 integral from 0 to infinity t power half e power minus t d. And this term we can write it as integral from 0 to infinity t power 3 by 2 minus 1 e power minus t dt, because the gamma function like this, so we can take this is equal to gamma of 3 by 2. Gamma of 3 by 2 is 1 by 2 into gamma of 1 by 2. Gamma of 1 by 2 is square root of pi. So if you use these terms, we can get the integral value is h cross by m omega whole power 3 by 2 into 1 by 2 square root of pi. So the expectation value of x is 24 by 25 h cross by 2m omega whole power half cos omega t. Now we have to find the expectation value of p. So expectation value of p is m differentiation of differentiation with respect to time, the expectation value of x. So substitute, and if you differentiate, we can get it is minus 24 by 25 h cross m omega by 2 whole power half sin omega t. Now we have to find the Ehrenfest theorem. It is differentiation of expectation value of p with respect to time is equal to minus the expectation value of dou v by dou x. So you know the value of expectation value of p, and substitute, we can get it is around um, uh, minus 24 by 25 h cross m omega by 2 whole power half omega cos omega t, and the potential energy is half m omega squared x squared. So dou v by dou x is m omega squared x. So here if you find dou v by dou x the expectation value, it is expected minus m omega squared expectation value of x. So if you substitute, then we can get differentiation of the expectation value of p with respect to dt is equal to minus of dou v by dou x. So here the Ehrenfest theorem holds. Next, if you find when n is equal to 0, we can get E naught is equal to half h cross omega. When n is equal to 1, we can get E1 is equal to 3 by 2 h cross omega. So the probability is around 9 by 25 for E naught, and it is 16 by 25 for E1. You can take it from the equation level. Thank you.